Hello, everyone, dear researchers and attendees. It is an honor and privilege to be here today as a speaker, presenting our findings on 15-minute city. The topic of my presentation is Borderless 15-minute city, a method for refined mapping the urban proximity and diversity, a case study in Ex-Macello, Milan. Rapid urbanization and social inequality have created an urgent need for cities to adopt more sustainable, resilient, and equitable urban development models. The 15-minute city has emerged as a promising alternative to conventional models of urban development, emphasizing proximity and diversity as key factors of sustainable and livable urban environment. Proximity and diversity assume pivotal roles within the framework, facilitating efficient accessibility, time saving, social interactivity, vibrant neighborhood formation, and heightened resilience and adaptability. Through the promotion of these fundamental aspects, 15-minute cities have the potential to afford residents a superlative quality of life while simultaneously addressing objectives related to sustainability and livability. Even though this chrono-urbanism model and its derivatives have raised a high interest for academics, urban planners, and policymakers, most studies on the subject are limited to the prerequisite of neighborhood boundary, which is often criticized for the potential risk of gentrification. To avoid the uncertainty of the current 15-minute city model, this study contributes to developing an innovative method for measuring urban proximity and diversity based on the integrated modification methodology, a holistic assessment approach developed by IMM Design Lab, Politecnico di Milano. Integrated modification methodology is an innovative design methodology developed in the Department of Architecture, Built Environment, and Construction Engineering at Politecnico di Milano to improve the energy and environmental performance of cities seen as complex adaptive systems. IMM considers the city as a dynamic complex adaptive system composed of various interconnected subsystems. It analyzes the relationships between these subsystems and focuses on key categories, which are emergent properties resulting from the synergies between the subsystems. The methodology aims to optimize the arrangement and interactions of these subsystems to achieve better energy efficiency, environmental sustainability, and social well-being. IMM provides a holistic and iterative approach to urban design. It involves a multi-stage process consisting of investigation, assumption, transformation, and optimization. It emphasizes understanding the existing system, identifying weak subsystems as catalysts for transformation, testing and evaluating modification scenarios, and continuously improving the system's performance. Based on the IML theory, we are trying to improve the analytic method of the 15-minute model by figuring out the limitation of boundary in the current Model A, which explores accessibility to key services within a given boundary, and Model B, which describes proximity and diversity as a possibility to reach amenities for a block in a given buffer zone. Being different from them, we are trying to divide the research zones into a dense point cloud. Each point has its own 15-minute buffer zone. This could be obtained through isochron analysis. Then we are able to measure the proximity and diversity precisely for each point. The result will be heat maps showing the variation of above-mentioned urban properties. This method is aiming to deal with the challenge of balancing localism and regionalism by not restricting the research object as a district or a block, but viewing every point as an independent element that has its own proximity and diversity. Now let's move to the case study. Ex-Macello area is selected to conduct the detailed investigation. It is located in the southeast of Milan, with railways and main city roads separating into three parts. The chosen area is 3 kilometers by 2.7 kilometers, where the daily amenities locate unbalanced. Most services are close to the city center, while the outer parts are with the least services. This uneven distribution gives a possibility to examine the different scenarios. The daily amenities refer to the crucial services supporting the daily life activities of residents and contributing to the balanced lifestyle. And it is adapted to the open data provided for Milan. Achieving proximity to all these amenities implies a great deal of decentralizing services and facilities locally in order to equilibrate differences between districts citywide. The categorization of amenities varies from different researchers. The mayor's agenda for a green and just recovery puts health, school, social, commercial, leisure, and culture as groups, while IMM produces a more specified way for clustering the amenities, which is food, commercial, culture, education, green space, restaurant and bars, health facilities, sports, and public services. This specification helps to better layer different services and gives the possibility to go into details. Let's start with proximity. The basic model is to measure the linear distance between each point to the closest amenities. So for each point, it always has this value, no matter if it is in a 15-minute catchment or not. This distance is then divided by the equivalent walking speed. Each point may have its own equivalent walking speed, which is obtained through the analysis of its 15-minute isochron. The tendency represents the reliance on each specific service by the cells in the neighborhood. It can be seen that the reliance on services increases from the west to the east. However, parks and green spaces shows a relatively balance. Culture venues and sports facilities are highly reliant by the cells in Ex-Macello regardless of the long distance to reach. Based on the tendency, the time for each cell to reach the closest amenities is mapped as meshes. The green color represents the shorter time, while the red means longer one. The mesh helps to figure out the detailed performance of proximity for each point within the site, visualizing the general situation for each amenity category. On the bottom of each map, the reliance of each service is illustrated by the colored columns. The taller the column, the more frequently the service is used by the neighborhood. These columns illustrate if a specific service provider is efficiently utilized. Then we visualize the value as heat maps. This heat map shows the time for each grid to reach the closest service based on the categorization. The proximity heat map highlights the zones where the grid needs to spend more than 15 minutes, and this helps to filter the unqualified cells based on the 15-minute city theory. Based on the statistics, the average time gives the evaluation in general, which enables comparison with other case studies. After getting the time for each cell to reach the closest amenities of 9 kinds of services, each cell has 9 values representing the duration to reach the respective services. To define the general catchment of each cell, the dominant catchment is introduced, the value of which is the biggest within the 9 values. For example, in ID21 cell, the time are 0.37 minutes for food, 0.37 minutes for commercial, 6.56 minutes for culture venues, and so on. Above all of them, the time to reach the closest sport facility is the longest, which is 9.89 minutes. So, sport is the dominant amenity, and 9.89 minutes is the dominant catchment. After filtering the dominant catchment for all cells, the proximity by dominant amenity is mapped. The proximity by dominant amenity is characterized by the dominant catchment. This refined heat map gives an illustration of the general accessibility for each cell to all the amenities. This accessibility is using time to define the basic catchment, which is in coherence with the 15-minute model, who measures the proximity in time instead of distance. The statistics indicate that parks are well distributed, so the proximity to it is similar for everywhere in the site. But the time spent to reach cultural venues varies the most. By filtering the qualified cells, we found only around 64% of the cells are having a 15-minute neighborhood, although the average proximity is pretty satisfying. The proximity by dominant amenity is characterized by the dominant catchment, which indicates only the longest time for each cell. However, there are many cases in which the time for other amenities are different even though the dominant catchment is similar. Considering the following example, cell A and cell B have the same dominant catchment as 8 minutes, while the other times are different. By linking the 9 closest amenities, the summation of the parameters and the double dominant time can tell the total time to visit all kinds of daily services. The total demand time represents another proximity that differs from the general dominant proximity, explaining the convenience for each cell to visit all the amenities at one time. Now we move to diversity. We explore the way to measure the urban diversity without sacrificing the information on different kinds of amenities by introducing Simpson Diversity Index, which is widely used in the biological field. This approach offers a chance to introduce the 15-minute city theory, conduct additional analysis, and compare case studies. Each point or cell works as a sample with a predefined 15-minute catchment. Then, the services within 15-minute walking in a neighborhood are included for diversity analysis, which means the analytic boundary of each sample is not the edge of the grid, but the 15-minute buffer zone. Being different from most of the research, which takes the whole area as a sample and gives a general evaluation, this approach offers a chance to look deeper into each point in the field and find the variation of diversity, which helps to figure out the hidden cause of service distribution. Starting from the distribution of amenities, we can find the parks and green spaces are homogeneously spread, but restaurants and other services are much closer to the city center on the left. By counting the numbers of accessible services for each grid by categories, we got the individual accessibility. This is a preparation for the later diversity analysis. Because diversity, according to its definition, is a property about the richness of different values. Before that, let's take the accessibility of Category 1 food store as an example. The cells in the left zones can reach around 60 food stores in 15 minutes, but at the right side, the value is less than 5. Some cells are not even to reach one store at all. This counting is also applied to other categories, together with some statistics on average numbers and heterogeneity. Since we have counted the numbers of different categories, find that some cells have 9 kinds of services within the 15-minute walk, but some are with only 7 or 6 categories. So we map the value as normal diversity, showing the available kinds of services each grid possesses. The yellow and orange zones cover 35% of the whole site, missing 1 or 2 services. These may be the 2 following reasons. The first one is the concentration of railway and main roads reduce the equivalent walking speed, so that the users should spend more than 15 minutes to reach the services. 2. Some amenities are located too far from the cells, which reduces the diversity of these cells. To deeper analyze the diversity based on the number of services and find the difference between cells, alpha diversity is introduced. It is calculated by the Simpson Diversity Index and shows the heterogeneity of different services in one cell. The lower the value, the lower heterogeneity is, which means the more balanced each kind of amenity is. Again, we take cell A and cell B as examples. Even if they are accessible to the same number of services, but the type of services in cell B is more balanced, resulting in a lower index value. Even though the alpha diversity explains the degree of service balance, but it considers only the value in one cell independently rather than globally. So, if one cell contains fewer values, it is more possible to have higher homogeneity. To solve this contradiction, we introduce the beta diversity. Before getting the beta diversity, we need to define the local-based best cell that has more accessible services, and at the same time, these services are well balanced. Out of the cells with the 9 different types of amenities available in the scatter plot, they demonstrate that cell ID 854 has the best diversity performance when homogeneity and full range of services are taken into account. After the benchmark is selected, it is crucial to make the comparison with other cells. Beta diversity describes the similarity of samples to the selected benchmark. The lower the value, the more similar the sample is. In IMM, diversity and proximity play significant roles in describing the efficiency of urban services and street network. They do have different points of emphasis and evaluation standards. While proximity investigates actual time consumption, diversity considers a fixed time catchment, in this case, 15 minutes. So we overlap the beta diversity with proximity to find the best and the worst performed areas, which will give a guide for the future urban planning. What we can get from the result is that having a rich collection of amenities is a baseline. It is highly connected with the 15-minute city theory. Morphology is influencing the real walking speed and then affects the diversity. Take the middle Ex-Macello area as an example. The very low diversity comes from the low walking speed in this area by comparing with the neighbor zone, whose service degrees are similar. A large number of services may not always increase the diversity, but sometimes reduces the balance, resulting service concentration and inefficiency of land use. In conclusion, the above result supports the 15-minute model as a feasible method by removing the limitation of predefined investigation boundary. The refined maps of urban proximity and diversity contribute to researchers, urban planners, and policymakers for creating more livable, inclusive, and sustainable urban environments. Thank you so much for listening. If you have any questions or doubts, please feel free to contact us. For further information, please visit our website where a full list of publications on IMM are provided.